Today we're going to be graphing absolute value inequalities. By the end of this video, you should be able to graph absolute value inequalities and determine the solutions from the graph. First, let's take a look at an equation. Our equation is y equals absolute value of x plus 2 minus 6. If you remember back to our unit on transformations, we looked at a, h, and k. A is the number in front of the absolute value bars, which is 1. X minus h is inside the absolute value bars, so in this case h is going to be negative 2. And then k is outside the absolute value bars, so negative 6. This means that our graph will be shifted 2 units to the left and down 6 units. And since a is 1, it will not be stretched or flipped. So if I start my graph at the point negative 2, negative 6, then because a is 1, it means I'm going to go up 1 and over 1 in both directions for my absolute value graph. Then the question is, what are the solutions? Remember that solutions is another word for x-intercepts. So on this graph, we have 2 x-intercepts. The first x-intercept is negative 8, and the other one is 4. You can write them either as coordinate points or as a set. So now that we've refreshed our memory with equations, let's take a look at inequalities. There are a couple of extra things we need to remember about inequalities. First is that sometimes you have a solid line and sometimes you have a dotted line. If you have a greater than or less than symbol, you're going to have a dotted line. If you have a greater than or equal to or less than or equal to symbol, you are going to have a solid line. The second thing you need to remember is that you also need to shade an inequality, which we'll look at that in a minute. So, our first example here, we have the inequality y is greater than negative absolute value of x plus 1 minus 5. So if we look at a, h, and k again, a is going to be negative 1 because there's a negative in front of the absolute value bar. H is also going to be negative 1 because we have x plus 1 inside the absolute value bars. And then k is negative 5. This means that we're going to start our graph at negative 1, negative 5. This also means that since a is negative 1, our graph will be opening downward. So I need to go over 1 and down 1. Now before I connect these points, since I have y is greater than, I have a greater than symbol, that means I'm going to use a dotted line. Now for the shading. You need to look at the direction of the shading, whether it's greater than or less than. So if you have greater than or equal to, you're going to shade above the graph. And if you have less than or equal to, you're going to shade below. So in this example, we have y is greater than, so I'm going to shade everything that is above this absolute value graph. Okay. So that is the graph of the absolute value inequality. Now, there's this line underneath that says, is blank a solution to the inequality above? So I'm going to pick a couple points, and I want you to try to figure out whether they are solutions or not. The first point I'm going to pick is this point, which is the point 1, -7. Then I'm also going to pick the point 2, -2. So are these points solutions to this inequality? Now, the first point I picked, 1, -7, is on the dotted line. Since it's a dotted line, all of the points along that line are not solutions. If it was a solid line, that point would be a solution. Now, the point 2, -2 is clearly in the shaded region, so that is a solution. Let's take a look at the next example. We have y is less than or equal to 2 times the absolute value of x minus 1 minus 3. So if we write out a, h, and k, a is 2, h is 1, and k is -3. So I'm going to start my graph at the point hk, which is 1, -3. Now, since a is 2, that means I'm going to go over 1 and up 2 for my graph. Now, since this is a less than or equal to symbol, I'm going to have a solid line, so I can go ahead and connect those dots. Now, when I get ready to shade this, it says y is less than. That means I'm going to shade below this graph. Now, I'm going to pick a couple points, and you're going to tell me if they are solutions to this inequality or not. The first point I'm going to pick is the point -1, 1. And then I'm going to pick the point 1, 2. So, since this is a solid line, all of the points on the line are also a part of the solution set. So the point -1, 1 is a solution. The point 1, 2 is in the not shaded region, so it is not a solution to this inequality. The tricky thing about absolute value inequalities are remembering that sometimes you have dotted lines and remembering to shade.